Hi guys, how are you? Welcome to our show. We're really happy to work with Math League because we find that they give everyone a chance to go and play with some interesting math problems on a regular basis. That's every month. So this
Oh, I think we have a frozen Professor Loh.
Oh,
Maybe that's what you get for
yeah.
poking your head out of the airplane while you're at like some 9 kilometers height.
No, I think that's a very normal thing for him to do. If you like
Oh,
check his Instagram, that's like something he would probably do.
yeah, probably. Anyways,
Yeah.
good morning
Hello
or
everyone.
good
Or
evening,
good night.
everyone.
Good night for me as I am not in China right now, so
It's,
good
it's a
evening
lovely morning.
everyone, or whatever time zone you're in. Hello. Welcome.
Hello. So we are doing a live solve of Math League, and while
Yeah.
Professor Lowe tries to be unfrozen, I drew a Ratchelate for everyone to enjoy. Good morning,
Oh,
afternoon, and good
good
evening.
evening.
So should we introduce ourselves first?
Ourselves.
Because,
Oh,
well, we have a lot of new people here.
mm, yeah, we do.
Hi guys, how are you? Hi guys, how are
So,
you? Welcome to our show.
oh, I see. I
Right.
see Professor Lowe's trying to get here.
Um.
So, thanks, Taya Pitram. Did I pronounce your name wrong? If I did, sorry. Oh, you're so good at drawing. Okay, well,
Hi
why
guys,
did you
how are
record
you?
a video and
Welcome to
not
our
share
show.
it because
We're
you thought,
really
hey,
happy to
knowing
work
him?
with Math League because we find that they give everyone a chance to go and play with some interesting math problems on a regular basis. That's every month. So this is our tradition, the second Sunday of the month. And so I'm really happy to be able to say that our live solve today is being run by two of our incredible live instructors. As you can tell, am on an airplane, so I'll have to pass it off to them. I also want to say I'm really happy the number of people we're able to reach through all of this. For example, if Lincoln, if you're in the audience right now, here's a shout out to you. I actually just met one of our audience members at a math contest out in Florida yesterday. I hope that someday I'll even get to meet some of the others of you. Who knows? But anyway, today we're going to go and discuss the problems that were on the most recent contest. So with that, I'll pass it off to my colleagues. Take it away.
All right.
Right. And
Hello.
hello,
We should
everyone.
go.
Yeah. And with that, I think it'll be good for us to actually introduce ourselves first as colleagues.
Hmm.
Um, so how about, all right. So first, I will introduce Elma over here. So Elma is from China. She is a devout follower of the yellow pig and the number 17. A very good number choice, I would say. And as a hardcore mathematical modeling enthusiast, as she proclaims, she has a meritorious award in HIMCM 2021 and was a regional finalist in IMMC 2022 and has authored at least 3 research papers in applied mathematics. She got top 1% in AMC 8 in 6th grade for competition math and qualified for the Amy in 2022. And what she does in her spare time is just build a fantasy world full of characters, draws digital art, and writes their stories. And she also enjoys hosting and playing Mafia or Werewolves in online forums. So everyone give a warm welcome to Elma.
Thank you all. And I'll introduce Benjamin. So he is a senior from Tennessee. who has a passion for learning and teaching mathematics. He is a 2 times Amy qualifier, more than me. 2025 USAMO participant and USAMTS perfect scorer. Wow, that is much better than gold medal. He also helps coach his school's math counts team, and outside of math, he enjoys programming, playing the piano, billiards, video games. Wow. Yeah, Kyle, Mafia is a good game. If you want to play some nice Mafia, come to MafiaUniverse.com.
Nice plug-in. May check it out. I would probably check it out if I do have time. Alright.
Okay. Anyways,
So,
should we start our live solve problems, and like we can like each do one and alternate, and if we get into a challenging problem, we can help each other.
yeah. How about we do that? Would you like to start off, Elma?
Yeah, okay. So we first have... Oh wait, this is not a problem.
Oh.
Oof. Oh, did someone eat my problems? Oh wait, that's just an empty slide. Yeah, here's the problem. So we have a guy named Silas. He scores 97, 94, 96, and 99 points on his first 4 math quizzes. However, he gets sick right before his first 5th quiz, so he only scores 23 points on it. At least how many points must Silas score on his 6th quiz for his average number of points earned on all 6 quizzes to be at least 80? So, let's see. Well, Silas is an interesting guy for sure. Well, even when he's sick, he also comes and does a test. So, what do we do when we first see like average? So, original at or the original is 94, 6, 99 divided by... Right, and then after he gets sick, he gets like another 1. So we have this. And now we have another test that we don't know which it is. So that's 97 plus 94 plus 96 plus 99, 23 plus... I'll just call it A, I guess, for a test. And that divided by 6 has to be at least 80. Correct me if I'm wrong on this. Oh, I see a lot of answers in chat saying 71.
Oh, wow.
It's this.
That is quite a few answers right there.
Yeah, so I think crowd consensus is 71. But to be sure, we'll also do this, I guess. We'll also like calculate it and verify it for you. So I'll remove this, move it to the other side, and then we just subtract all of that from 80 times 6. And since I'm... Wait, so do I rely on crowd consensus or do I just calculate it? Okay, so I see so many people say 99 something. Oh, and since I am not the best mental math calculator, Benjamin has helped me write out the answer, and indeed, all of you are correct.
It's correct.
It's 71.
It is
Yay,
71.
Nice try, everyone.
Good job to everyone who got it. So, as we got through that really quickly, I think we may be able to get through quite a few problems today. So let's move on to our second question. And indeed, our answer was 71. So let's move on to our second question here. So the number 192 has n positive divisors. If we let m be the greatest common divisor of n in 343, what is the units digit of m to the nth? There's a lot of strange conditions right here. So I believe the first thing I would we should probably attempt to do first is digest this first condition here, because M relies on that first condition. So what does positive divisors mean? Well, that would just be anything that divides 192. So maybe I could list a few out. Maybe there's like 2. I believe 3 is one of them. 6, and then so on and so forth. That seems like it would take too long. Hold up. Yeah. Okay. So how about we instead try prime factorizing 192 instead? That maybe will give me a little bit better insight into this. So if we split up 192, I know 3 goes into it, as I stated previously. That should be 3 times... Hold up, I can't do mental math. I believe 64. And then, well, I know 64 is just 2 to the 6. So 192 is just 2 to the 6 times 3. 2 to 6 times 3. Now, how does this help me get the positive divisors here? Well, what we can notice is that if we try to consider some kind of positive, if we list them all out, right? We have 1 or 2 to the 0th here. I'm going to write it like this: 2 to the 1st, 2 squared, all the way up to 2 to the 6. So we have a couple of choices for what factor of 2 we can put into our positive divisor here. And then we could also either include a factor of 3 or not include a factor of 3. For example, it would be 2 0 times 3, or 2 to the 1st times 3, and so on and so forth, all the way up to 2 to the 6th times 3. And if we count this up, we can see that, as a lot of you are in chat are stating, or some of you in chat are stating, we get that n should be 14. So let's move everything else to the side now, since we have what we need. Let's to the side and keep this in mind. So now we just need to compute m from here. So, and as a lot of you are stating in chat, because m will just be the GCD of 14 and 343. What is 343? Well, it's quite conveniently, as Elma's pointing out, 7 cubed. And since 14 is just 2 times 7, we then have that m just must simply equal 7. So now we just need to compute what the units digit of 7 to the 14th is.
Okay, that's another one. That's another loop.
That's another third thing we need to get done. Well, how about this? I do know, let's compute a couple values first, because let's see, because we would like to find what this is congruent to mod 10, right? That's the same thing as finding the units digit. So 7 is obviously congruent to 7 mod 10. 7 squared is just congruent to 9 mod 10, which is because it's 49. Then we also have that. So let me clean this up really quickly, because we have everything here. I mean, we also have that 7 cubed. That's just, we already know that's 343. That's 3 mod 10. And then, how convenient. 7 to the 4th is just congruent to 1 mod 10. Interesting. So, what this suggests to me is that we can reduce this 7 to the 14th into maybe, let's say, 7 to the, let's see, we can raise this to 7 to the 4th cubed times 7 squared. And we already know that 7 to the 4th reduces to 1, so this 1 cubed factor just goes away for us. So this will just reduce to 7 squared, which we know reduces to 9 mod 10. And this should be our final answer, as a lot of you are spamming in chat right now. Right now. And
let's move on and check the answer, shall we?
Let's check our answer. So really quickly, it is 9. All right.
Yes.
Let's go.
Yeah.
9.
Proud
Congrats.
consensus wins again. I see so many people sending 9 in chat.
In chat, clap, 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 claps for everyone here.
Yeah. And now we have a probability problem. So a bowl contains 5 red grapes, 4 green grapes, and 3 black grapes. Wow, I didn't know that grapes have so many varieties. And Gary, who is the snake from Zootopia 2, randomly chooses 3 grapes from the bowl without replacement. What is the probability he chooses 1 grape of each color? So I'm gonna draw the grapes here then. So 5 red, and then 4 green, and then 3 black. And since the black does not show up, I'm gonna have to use white. So we have Gary, who is here, and so I'm just gonna see. When we see this kind of probability problem, we usually have something that's all the scenarios over stuff we want. Stuff we want over all the scenarios. In Chinese, we actually say what's down first and then what's up. So that's why I got it messed up. So we have, how do we get what's up? So for the thing that's down, it's just like 12 times 11 times 10, right? We just select 3. And for what we want, we have 5 times 4 times 3, since it's 1 from red, 1 from green, 1 from black. Yeah, so wait,
No.
Hold on. But then we need to think of overcounting. Because this gives an obvious intuitive answer. But doing this, I just feel like there's something with order that we did not figure out. Benjamin, did you have any ideas on this?
I don't think this is more of an undercounting issue. No, not an overcounting. I think it's more of an undercounting issue here, actually. Because, what we've just done here with the 12 times 11 times 10 is that's assuming that we do have order, right? Because we have 12 grapes, we're choosing one of them, then we're choosing one of the remaining 11, then one of the remaining 10. And we're putting those in order already. But with our 5 times 4 times 3 here, we aren't actually accounting for order. Because let's say our 5, we account for this red grape, then maybe this green grape, and then this black grape, pretend it's white, pretend it's black. But what if, because I'm saying that I select this first, then this second, then this third. However, maybe I go a bit different. Maybe I choose the green grape first, then the red grape second, then this third. So what's happening here is that we're undercounting this by not actually representing the true order that could occur. But since we are accounting for order in the bottom, we need to also account for order in the top. So how do we do that here? Well, how many ways are there to order the three grapes after we chose them? Well, it's just 1 red, 1 green, and 1 black. So we simply have, how many ways are there to order them? 3 factorial. Factorial, which is just 6.
Yeah, so now we find out that we are actually undercounting. So for a quick save, we multiply a 6 on top. And that'll probably make it ordered, right?
And that'll add order, and that'll give us the ordering we would like, yes.
Yeah, and now it's time to simplify. So we got 6, and we know that 12 is 2 times 6. So we just delete these, and we got 12. We got this. And also we know that 5 times 2 is 10. So actually, 5 times 4 is just 2 times 10. So we just remove all of those. And and then after eliminating everything, we have 3 over 11.
3 over
Which
11.
we think
Yeah.
Now what's the answer?
Which a lot of you are saying, but some of you are still, as we stated previously, some of you are getting the answer of 1 over 22, which is the same pitfall that some of us has come over, where you're trying to compute the bottom part, or either the top or bottom part, one with order, but then you're computing the other one without order. And that's what's leading you to get this 1 over 22 answer here. So here.
Yes. So now it's 3 over 11, which is crowd consensus. Before I see a lot of 1 over 22. Just remember, order sometimes matters, sometimes doesn't. And if we want them, then we better order the orders.
And as we can see, what is the answer? That's right. It is 3 over 11. Or 11. Yippee! Yay. Everyone, as Chad has consensed with everyone here, pats on the back for everyone. That is a little bit of a pitfall that many can fall into. So our next question is a little bit of a doozy. In fact, I couldn't even make it as big without covering my face, my beautiful face. So let's go through this. So Max the Magician has 5 not necessarily distinct positive integers: a1, a2, a3, a4, a5. The integers have the following property: the integer a1 leaves a remainder of 1 when divided by 3, a2 leaves a remainder of 0 when divided by 3, a3 leaves a remainder of 2 for 7, a4 leaves a remainder of 6 when divided by 7, and then a5 leaves a remainder of 7 when divided by 9. And then using this information, it is known that integer a, I believe this should be a sub n for sum here, sub n here, because that's the only thing that makes sense. And then it is known that a sub n cannot be a perfect square. And then we would like to know what is n here. So let's let's first go through each condition. Well, what does it mean for an to be a perfect square? Well, that just means it can be represented, well, there we have a couple perfect squares that we know, like, 1, 4, 9, and so on and so forth, like this. So let's go through each of these conditions and try to whittle them down. So A1 here gives us, well, if A1 just simply equals 1, 1 is a perfect square, right? And that leaves a remainder of 1 when divisible by 3. So we know that this cannot be our answer here, because we can just set A1 equal to 1. Now, what about A2? Well, same thing. What if A2 just equals 9? Well, 9 is obviously divisible by 3. Does this give us... So, this leaves us a remainder of 0. But 9 is a perfect square. So, this cannot be it. Now, what about A3 here? A remainder of 2 when divided by 7. Ugh, that's a little bit weird. Well, let's think about what are some numbers of the same thing.
Just look up.
Yeah, just look. My bad. So, as Elma has already pointed out with everything else, we can see that a counterexample to this one is 9, and then for A5, it's just 16. 16, which is quite convenient. So, we don't actually need to compute everything else, since our n has to be either 1, 2, 3, or 5, 1, 2, 3, 4, or 5, as by the question design. And we've already ruled out all other 4 options. We must have that A4 cannot be a perfect square. So n must equal 4. Oh, I'm writing over chat. Equals 4. And if you would like to check this, then you can just check all of your perfect squares, modulo 7, and then just see that the only possible remainders are 0, 1, 4, and 2, I believe. 2 and 4, I believe. Yeah. And 6 is not in there.
We can also invoke in some complex group theory or something, and then like make a modular group of all these squares and stuff. But that's all pretty overkill. We can just sometimes just find out that which of these are the ones that do not work, and then since there is one that has to work, it's gotta be that one.
Yeah.
Right?
Yeah. As a lot of people would say, myself included, if the dumb method works, it works. You don't need to be intelligent. If it works, it works, you know. That's all that really matters. What is modulo? For any of those not familiar with like this, it's like modulus in this case is just like remainders. They're basically equivalences of by remainders, so as a lot of you are pointing out in chat. For those of you who are not aware. Alright.
Mm-hmm. So, should we move on to the next one?
So, if we...
Let's go.
So you see, we have 9. So, let's move on to our next one. And it's even more words. Oh.
Yay, I'll read it. I'll read it so you can get some water. Jack is painting a set of 15 identical cube-shaped blocks. And he needs to paint every face of each block. The blocks have edge lengths of 8 inches. Given that each bucket of paint covers 140 square inches of area, at least how many whole buckets of paint does Jack need to paint all his blocks? So, this, for starters, is a block. And how many faces does a block have? Well, please send in chat how many faces a block has. Oh, 3? Does a block have 3 faces, or is that the answer? Because, yeah.
I think I know one of my it's 6. I know one of my friends who thought a block had 8 faces, and they missed a question on a physics test because of it. It's okay. It's okay.
They were thinking of like the 2 tetrahedrons smushed together platonic solid. But anyways, a block has 6 faces, and we have 15 blocks. So how many faces are there? Well, there are 15 times 6 equals 90 faces. And after that, they have edge lengths of 8 inches. So this is 8 inches. What's the area of an entire face? Well, let's see. That's just 8 times 8 equals 64. I can already see that this is gonna be a bashing problem. So, and I am not the best at those. So then we have the total is, say inches squared. We gotta be careful with the units. So, then for total area is...
I'm just gonna leave it like this. We'll deal with it later. We can deal with that later.
90 times 64, I guess. So the total is 90 times 64. And then I'm not gonna calculate that out because that's just more bashing, but you can calculate it, the total area. And then the buckets is just that. Over 140, right?
Yeah. Unfortunately, that number there is not divisible by 7. So this quite unfortunately means we are going to have to do a little bit of bashing here. Here. And as we
7, something over 7. I'll calculate it.
Reduce it to be 32 times 9 divided by 7, which is, I believe, 288 divided by 7. Well, actually, that's not too bad, actually. It'll be 288 divided by 7. Well, what's the closest integer we have to 288? Well, that is divisible by 7. Well, 28 is just 7 times 4, and, well, we can just see from there that 287 is our closest integer. But it's a little bit greater than that. So, and then we can approximately see that this is going to, like, be 41 point some random garbage over there. But since we need to cover everything, we can't just have like a little spot left over. this means that we need to have at least 42 buckets, as a lot of you are spamming in chat.
Yeah, so it says at least how many. So you can't just go with 41 buckets and then leave something unpainted, even though it is waste and there's climate change and global warming and all of that. You do need to open a whole new bucket to just get that tiny part painted.
Which is very
Let's
unfortunate,
see.
but yeah.
Great job,
Are we
everyone.
correct? We are correct. The chat's consensus is right. All right.
Oh god, everyone's standing over Rat Sheila in chat. But you've got to focus on math.
Yeah, y'all gotta focus on math. You know, if you annoy Rat Chile too much, he's not gonna give you your gold stars anymore. And we don't want that here, do we? All right, moving on to our very next problem, which looks like counting but bashy, which is unfortunate. So Caitlin buys apples, bananas, and cherries at the store. She can only buy whole fruits, and she buys a total of 13 pieces of fruit. Given that she buys at least one, but no more than 6 of each kind of fruit, how many different sets of apples, bananas, and cherries could Caitlin have bought? Assume that 2 fruits of the same type are identical. Alright, so we need to figure out what we should do with this condition. So let's first deal with. I want to get rid of this at least one condition here. That is a very. I don't like that condition. So to remove this condition, we can instead, since we know, let's say we have our apples, our bananas, and our cherries, we can just give each of these a tally of 1 immediately, so that we buy at least 1 of each. Then we can just subtract 3 off our total to give us 10 remaining fruits that we could allocate to A, B, and C. But we also need to reduce this second condition down, right? Condition down. So since we are already buying at least 1, we can translate this condition to be instead at most 5 now. 5. Adding on this extra 1 that we already had. So now, how do we count this? Well, the unfortunate part is that I don't think there is a very nice way to do this. That isn't just complete writing everything out. Just writing out. At least I can't think of one right now. Can you think of one, Elma? Or
let me think. So no more than 6 of each kind of fruit, and then so that means at least 5. And then I see someone say here that it's casework. So let's do some casework.
We can do casework. Some people are saying sticks and stones / stars and bars in chat. The unfortunate part about stars and bars here is that you still would have to get rid of the excess, because stars and bars also includes what happens if you just buy 10 apples instead now. So you have 11 apples, 1 banana, 1 cherry. That's not allowed, is it? So that is not good for us. So either way, we're gonna have to deal with a little bit of casework here, which is unfortunate. So how about let's start with some casework. And Elma, would you like to start?
Yeah, okay, so let's say, I'll just say apples is 5. Okay? And we just clock that. And so for the other 2, we have 10. We have no, not 10. We have 8 in between the 2. And for 8, we can either have, we must have like both of them not bigger than 5. So we can only have 5, 3, 4, 4, and 3, 5. So this is 8. And then
if you,
right?
also, if you're gonna be okay, sorry, Elma. Slight error, we would have at most 10 fruits because we already like subtracted one off for each separate.
Oh,
Yeah,
I
so it'd
see.
be like 5, 0, 4, 1, and then 3, 2, and so on and so forth.
Okay. Then that's just easy because for 5, we just have. Okay, so then it's 10 total, and that's 5. Then we just have like 1, 2, 3, 1, like from 0 to 5, and that's just like 6 cases, right? That's just 6 cases.
Yeah.
That's actually easier than just counting everything. And then we go to 4, which I think we can still like do reasonably without like 5, 4, 6, and okay, I think we can still do reasonably, but we have to be careful because we cannot assign 6 to any one of them, right? We can't, right?
No, we can't.
So no more assigning 6. So that's actually 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. That's 5 cases. And this is 5 cases. And then we start to find out that maybe there is a pattern in between them based on like what the total cases is, like whether it's odd or even. Because like for the even one we have 3, 3. That's was both the same, but for odd one we just have 3, 2, 2, 3. And then it's not the same. Maybe that can help simplify stuff because I don't like bashing.
I think there is a pattern here in your casework. Like when A decreases, it seems like the possibilities also decrease by the same number. So for like A equals, if we have 5 apples, there are 6 possibilities. If there are 4 apples, there are 5 possibilities. And then 3 gives us 4 possibilities, and then 2 gives us 3, and then I presume that it would go on the same way. On and on. So how many of these are there? There are 6 cases. Well, A can be between 0 and 5. 0 and 5 here. So I would presume that the next case, A equals 1, would also have 2 possibilities. And then case 1 would have 0 possibilities. No, not 0. 1 possibility, which is B and C are both 5. So by adding all of those up, we can do 1 plus 2 plus 6. Oh, that's on me.
And then we learn from a person who calculated 1 plus all the way to 100. And then we just do start plus finish times numbers divided by 2, which is 1 plus 6 times 6 divided by 2, which is 21. And I see crowd consensus is also 21.
Crowd consensus, everyone is also getting 21 here. So let's see if we are correct or not. And indeed we are. Alright, congrats everyone. Everyone. Now, if the number was slightly larger, maybe let's say we had at most, I don't know, 20 apples, who knows, some big number, maybe then we could use stars and bars here, because complementary would be better. Would be, well, I guess less casework per se. But
yeah.
With that, we can move on to our next question. And it's even more words. My favorite.
Okay. I'll read them. For any real number x, let x inside curly parentheses represent the positive difference between x and the greatest integer less than or equal to x. So it's like x minus 4x, kind of. That's the 4. I use it a lot in CS. So, for example, 3.2 curly parentheses is 0.2. 4 curly parentheses is 0, obviously, because it's a whole number. And negative 1.2 curly parentheses is 0.8, because the number that's smaller to it than it is actually negative 2. What is the sum of values of k squared for the 5 smallest positive real numbers of k that satisfy the equation k inside these curly parentheses is equal to 3 over 5. Wow, that is a lot to unpack. And
Truly is.
once we, yeah, holy. And so let's see. For the 5 smallest positive real numbers, so it has to be positive, it has to be real, and it has to be smallest. So, and this k thing is 3/5. So I'm thinking from this, we can probably see that the 5 numbers are something like 3/5, 1 3/5, 2 3/5, 3 3/5, 4 3/5. Is this a reasonable guess?
I would be inclined to believe so as well.
Okay, so I see a lot of people sending very different answers in chat.
So
And
this one is quite a bit of a doozy because, well, it's not just simply asking us for the fractional part of k, it's asking for the fractional part of k squared, which is bad, because what does that mean? We have to bash now. Alright. So, how do we deal with that? Well, let's simplify these top parts. 3/5, 8/5, 13/5, 18/5, and then 23/5. Then
oh, also, I hear someone saying, what is bashing? So bashing is basically like just calculating stuff without using like other smarter methods. So just trying and then like just calculating a lot of stuff.
yes, bashing is basically what we like to call not wanting to think not wanting to think smartly. Instead, we just go head first in and just compute everything. Yeah, essentially just brute forcing, as some of you have stated. So, how do we do this? Well, me personally, since we only have 5 values to compute, I would just manually square everything.
Actually, I think there is a better method to just simply manually squaring everything, because I see all of the stuff is in the form of some a plus 3/5. And I can get a general formula of what it's like, because the a squared is just going away, and that's just the whole number part, and it does not affect what this curly parentheses is. So what really matters is just 2a times 3/5 plus 3/5 squared. I think we can do this better than just squaring everything.
You are correct. That is true. So,
So that's basically just 5 times something. Wait, that's just 5 times something, and then plus 9/25. So so like a single one of these just simplifies to this, and I think that'll be much easier, right?
yeah. Okay, yeah, I do believe this would be easier. So, let's go about doing that then. So, obviously, for a equals 0, we're going to get 9/25. For a equals 1, we're going to get, I believe it would be 39/25. But we have to take the fractional part of that, so we need to remove all the whole number stuff, and that would give us 14/25. We do the same thing again with 2 instead. I believe that should be 69/25,
Yeah.
which is just 19/25.
19. Ooh, do I see a pattern?
I do believe there is a pattern here. Now, it seems to be going up by 5 every time. Now, why could that be? Now, I don't really want to think about why that's
Let's
true.
do the
I'm
last-
probably just...
Let's just do the last two to make sure, shall we?
Yes.
So, because, like, if it's just the front two that has patterns, then that's not gonna mean anything. We need to, like, if there's a pattern, we either prove it or we have enough examples to make sure that it's a pattern. So, just like the Goldbach conjecture, you just don't say there's only two of them. You say there's a lot of them. And even if we can't prove it, we know there's enough examples to say it's probably true. So, since it's 5 times 4 plus 9 over 25, it's already done. 5 times.
It wouldn't be
Wait.
5 times 4 directly. It would just be... Because you forgot, like, the 2 in front. It'd be like...
Oh, yeah. Wait, hold on.
And also a little bit more. It's times 3/5. So, for 3, I already... Wait, did I compute it properly? I think I did. 3, I computed that would be 24th over 25th. And then by our little guess here, I would presume that if we multiply this by 4, we should get something, or the fractional part of 29 over 25th. But that is divisible. But there is some 25 in there, so I would presume that this would just be 4 over 25ths now.
Yeah.
And we can manually verify this by just plugging 4 in. Should be 8 times 3 times 5, which would be... Hold up, I can do mental math, guys. 120. So, 129 over 25, and this would give us 4 over 25. Alright, there we go. So, now all we gotta do with that is just now add everything up. Which is very fun now. So, we get 23, then plus 19, that should be 42, then plus 28 here, that's very convenient, that will give us 70, and so we should get, as some of you had been stating previously, our final answer of 14/5.
Yay!
14/5, as some of you have
So
said.
for a lot of people who are confused, we simplified this a plus 3 over 5 squared into 5 times question mark plus 9. And then we know that like a is just 0, 1, 2, 3, 4 from here we listed. And then we plugged in each of them, got the fraction part, and then added them. So yeah.
To sum up what we just did here, we just computed everything.
Yep.
So,
Let's go.
now let's see if we're correct. Yep. We are right. Yeah.
Yay.
Yeah, alright. Let's move on to our next problem here. Oh my god! There's not that many words now. This is huge. This is very nice for us. Because that means I can actually read the problem very quickly. Now, the bad part about not that many words is that there's usually a very lack of information here. But in this case, I don't think that's the case, actually. So, we would like the least positive integer n that satisfies the inequality n squared divided by 2 less than or equal to 1.01 times n choose 2. Now, if any of you are not familiar with this choose function right here, well, this choose function is like asking how many ways are there for us to choose 2 objects out of n objects without order per se. And we can see by a little bit of counting that this would just be n times n minus 1 divided by 2 here. So now, what do we do? Well, plug it in, straight up. So, and we would like this times n minus 1 over 2. Look, that's covering my face. Now, well, I see something very nice. Since it's positive integers, we can just cancel this n and this 2 here. And so we just have n less than or equal to 1.01 times n minus 1. So, expanding, n less than or equal to 1.01 n minus 1.01. And this will just give us that very nicely. 1.01 will be strictly less than or equal to 0.01 n. And how do we just put this into form of n by itself? As Elma's pointing out, 1.01 is just 101. It's just over 100. So we can just multiply both sides by 100 now. And let me draw a big swoop-y arrow here. And so this will give us that n must be greater than or equal to 101. And since 101 is quite obviously a whole number, we can see that we can just set n equals to 101, as a lot of you in chat are saying. And we can see that this obviously has to work here. Work here.
Yeah.
All right.
And I see a lot of people asking in chat what inequality is. So inequality is basically the right thing has to be greater than or equal to the left thing. And we need to find the smallest n that satisfies this condition.
Yeah. And so, with that, let's check if we're correct. Well, I presume we are. Oh yeah, we are correct. As a lot of you are saying. Too bad, not too bad.
This question is so 101. Someone said.
No one.
Okay. Now, we have another word wall here.
Another.
Call a positive integer with at least 3 digits boxed if it has the property with that its first and last digits are the same and have values that are strictly greater than twice the value of any other digit in the integer. Interesting. For example, 52125 is a boxed integer, but 63336 is not, because 6 is 2 times 3. So it has to be strictly greater, which means it cannot be equal. How many 5-digit positive integers are boxed? I'm thinking this is requiring casework again. Box is squared? No, it's not. Why do all of the explainers have weirdly lit rooms? I don't know. Maybe it's because Rat Chile over here is on my screen. But boxed is just basically a definition of a garbage A. And this garbage, every digit of this garbage is less than A. So now do you understand? Yep. So I'm thinking we do casework on what A is. So casework. A equals 1 since it says 5-digit and we can't have A equals 0 because that's not a 5-digit number. And then the middle can only be zeros because it says strictly greater than twice the value of any other integer. So like it's less than. That's the only case. And for A equals 2, I think that's still the only case because it says strictly greater than twice that value, right? It's just still one case. And for A equals 3, we can either use zeros or ones between. And so that's just 2 to the third. I think we can just figure out like which kind of numbers we can use in the middle because how many we use doesn't even matter. Someone says it's a sum of cubes.
It's a sum of cubes.
Let's see if it's the case. Because if we want to find a pattern, then we gotta have like at least a few more examples, right? So if A equals 4, then we can still only use 0 and 1, so that's also 2 to the. And if it's A equals 5, we can use 0, 1, 2, which is... Oh, it is the sum of cubes, but be careful, it's a double sum of cubes. So we have, if it's 2 of 1, 2 of this, 2 of this, that's 1, 2, 3, 4, 5, 6. I'm assuming the next one is 4 cubed. It's a 7,
Cube.
8. And be careful, A cannot be 10 because A is a single digit number. So we only have 1 5 cubed or 9. And then we add all of this up. Yep. And a lot of people say the answer is 325. Well, I'm going to verify if it's the case. So let's go. 1 cubed plus 2 cubed plus 3 cubed. Why did it go on to the cube?
5 for that 1 plus 4 cubed to 100.
Wait. I think
Should
we
be.
miscounted some stuff. Because... Oh yeah, it is.
I don't believe we did. I believe calculators are strictly banned.
Yeah, but I want to speed up because we have so many problems and we have only 3 minutes.
Yeah, we don't have so much time to get through. Not in sprint? Oh, interesting. Okay. No? When we sum everything up, we do come to a consensus, as everyone is spamming in chat, of 325.
Yeah.
Just by manually calculating everything. Again. And we can check that we got the correct answer. And we have. Very nice. Now, let's see. Let me see if we have time to answer this next question. Nope, it's even more numbers. It's even more words. I think we would actually waste too much time to actually. I think we'd waste all our time to actually read the question out. So we'll leave this one up to you guys to figure out yourselves. I don't think we will have time to get to this one. Yeah, I'm sorry. It's just even more words than ever before.
Yeah, I think why it's called the sprint round, because like you need to do stuff fast. Like a lot of these problems we've done are very bashy and they need like a lot of calculation and quick to find patterns in between the calculation. And since it's called sprint, you have to do this in a relatively short amount of time. So it's not the questions themselves are hard, it's how you manage your time. And that's going to be more important than just having a high skill of math.
Yeah. You also need to be able to read fast. This is why everyone keeps telling you that English is important. You can't just be good at math and then fail English class. That never works out properly.
Right. You do not want to fail English if you want to do sprint or if you want to do math. Yeah, there's too much words. And also someone say calculators are banned. So if calculators are not banned, then how to use a calculator is also very important. If calculators are banned, then I think having some mental math like him, like Benjamin, and not me, is more important.
Alright.
So, did anyone figure out this problem on your own? Because if you did, then you can, of course, type it inside chat for all of us to see how good you are. And then you're really qualified to go to Math League. Oh, I see a lot of people say square root 65, 6, 67, 41, 6, 7, 41, and...
A lot of people are saying 47 here. Saying 6. And people are, of course, saying 6, 7. Quite unfortunately.
I'm sorry to say Benjamin is, of course, better than mental math than me, because I have dyscalculia. I do a lot of things with long division or long multiplication and with calculators. So there's no question over there. Oh, I think we should trust crowd consensus that this one is 47. We should just reveal the answer to them to see if they're correct.
Yeah, alright, let's see. Is chat better than us at math? Let's see here. Chat is better than us at math. We do get the answer of 47.
47.
7. And
Congrats to everyone with 47. If you wanna know why, then you can figure it out. Or you can come to live classes where we solve a lot of questions like these. And we will also have Professor Loh and us explain it to you guys at the board more clearly than what we do now.
yeah, we actually will have Professor Loh with us, unlike when he's stuck on a plane, unfortunately.
Yeah,
Unfortunately, Professor Loh will be with you guys as well.
Yeah.
Alright.
So, with that, we wrap up our live soul for today. Great chat. Chat is better than us at Math Olympiads. Yes.
Chat is definitely better than us. Well, it is our time to say goodbye now. It is a little bit past 7:30 already. So, everyone have a great day. It is time for me to actually go eat dinner now. So, alright. Bye, everyone.